Today we are going to cover section 4.2, topics in the theory of polynomial functions. So take the time to copy your title, your essential question, how do you divide a polynomial by another polynomial, and interpret the results. Paste your cutout, write example number 1, and read through your cutout. This is something that you guys covered last year, and it should be a quick review, plus a little more depth. Go ahead and pause it, and we'll continue once you are ready. So the division algorithm. If f of x and d of x are polynomials, such as d of x is not equal to 0, and we are going to be dividing those two polynomials, so therefore we don't want the denominator to be 0, because otherwise it will be undefined. The degree of the d of x is less than or equal to the degree of f of x. There exists a unique polynomial q of x and r of x such as the following. So therefore, when we're dividing, the degree of the divisor has to be equal or less than the degree of the dividend. And q of x will be your result, and r of x will be your remainder. Now notice that those two expressions are equivalent. Do you see that they're equivalent? And we can actually convert this equation into this form. By multiplying by d of x, and d of x, the d of x will cancel, and the d of x will cancel. So therefore you have f of x and r of x by themselves. And we end up with d of x and q of x. Where r of x is equal to 0, or the degree of r of x is less than the degree of d of x. So therefore, you're going to stop the division when the remainder is 0, or the degree of the remainder is less than the degree of the divisor. Now, and we'll go over this on example number 2. Now, if the remainder r of x is 0, so if you end up with the remainder of 0, then d of x divides evenly into f of x, correct? Just for example, if we have a division, if you have 42 divided by 3, and we actually go through the division and place your dividend, 42 divided by your divisor, 3. And then we just go through the process. 3 goes into 4 one time. And then we go through 1 times 3 is 3. And what do? We subtract, gives us 1. Next step is to bring down the 2. And then we go through the process again. 3 goes into 12, 4 times. 4 times 3 is 12. We subtract, it gives us 0. So therefore, we stop once it's 0. And if your remainder is 0, that means that 42 is equal to, we're going to write down your divisor first, which is 3 times 14, right? It divides evenly. And that's basically what this is saying. Now, let's go through example number 1. Let's go through and recall long division. Long division is just a process, just like long division that you learn in, what grade will it be? 5th grade, probably. So therefore, we're going to place your dividend inside. And one of the things that we have to be careful is that we have to make sure that we have each of the terms. So notice that the degree of the polynomial is 3. We have x to the third power. So therefore, we should have an x squared, and we don't. So we're going to place a placeholder. We're going to write a placeholder in here, x to the third. We don't have x squared, so we need to make sure that we have place x squared minus 14x minus 20. And the divisor is 2x minus 4. And we're going to go through the same process like we did here. But let me just go through, let's go through it again. But now I'm going to divide, let's try 44 divided by 3 instead. So we have an actual remainder. So how do we divide? We should go through 3 goes into 4 how many times? 1. 1. So we're going to go through the same process. 2x minus 4, but we're just going to say 2x goes into 6x to the third how many times? Now, it'll be 2 times 3. And how many more x do I need? X squared. Since I need x squared, the proper way of doing it is to place it here. But it doesn't really matter. For my purposes, I'm just going to place it on top of the x squared. So 2 times 3 gives me x squared. X times 2 times 3, 2 times 3 will give me 6. X times x squared will give me x to the third. Now, we usually multiply 1 times 3 will give me 3. So in the same manner, I'm going to multiply the 3x squared, not just by the 2x, but also by the both. You multiply by them both, and you place them underneath. 3x squared times 2x will give you 6x to the third. 2x squared times negative 4 will give me negative 12x squared. And now, what do? We subtract. 4 minus 3 is 1. But we actually should be changing this to a minus to subtract it. So the same way that we're going to change this to a minus. But instead of just changing it to a minus, we're basically just going to do it, since we have to use the distributive property, I usually just do that once. So negative times a positive is a negative. Negative times a negative gives me a positive. And now I add. So that cancels out. And this gives me positive 12x squared. Now what will be the next step? You bring down the 4. So in the same case, I'm going to bring down the negative 14x. And what will be the next step? We continue with the process again. 3 goes into 14 twice. 2 times 3 is 12. Then we subtract. It gives us a 2. So 2x goes into 12x squared. How many times? Positive 6, and I need one more x. Do you agree? And now I multiply it out just like I did here. 6x times 2x will be 12x squared. 6x times negative 4 will be negative 24x. The same way that I change it to a negative, we want to change them both to the opposite. That becomes a negative, and the negative becomes a positive. And now I'm going to add. That cancels, and that should cancel every single time. This gives me 10x. And what should I do? Continue, bring down the negative 20. And now I continue with the process again. Remember that they have the same exponent. I'm going to stop once my remainder has a smaller exponent than my divisor. 2x goes into 10x, positive 5. 5 times 2x gives me 10x. 5 times negative 4 gives me negative 20. And what should I do? Change the signs. That cancels and that cancels. So I end up with 0. So therefore, since this is equal to 0, I can rewrite it in this form, the same way that we did it. So I'm going to use this form to rewrite it. So therefore, I'm going to say that f of x, or 6x to the third power minus 14x minus 20 is equal to I'm going to use my divisor by my quotient. So my divisor is 2x minus 4 times 3x squared plus 6x plus 5. And that's how we're going to write down in once we actually are working on example number 304. But another way to write down is that 6x to the third is in this form, and that's how you guys saw last year. And sometimes you guys will see that on the test as well. 2x divided by 2x minus 4 is equal to, we have 3x squared plus 6x plus 5, and there's no remainder. This is equivalent to that. And you see that if you multiply both sides by 2x minus 4, you end up with this. So on the next section, on example number 7 and 8, so hang in there, we'll be writing it down in this form, but for now we're going to leave it in this, on example number 2. So you got this? Do you remember from last year? Excellent. So let's go through example number 2. Write it down, copy it down, and then we'll start once you are ready. Excellent. So in this case, I'm going to use my long division. I want to write down my dividend. Make sure that I'm not missing any exponents. X to the third, so 3 is the degree. X squared, I'm missing a x. So we have 5x to the third minus 4x squared plus 0x plus 1. And my divisor is x squared minus 3. So notice I don't need to place an x or a placeholder for my divisor, but I do need to place on my dividend. Okay, so now that I set up, go and work through the process, and then once you finish, we need to be able to write down our answer in this form. Go and pause it. Excellent. So at this point, you should have finished, correct? If not, let's go through the process. Let's see. We're going to start. X squared goes into 5x to the third. How many times? So we're going to need an x. I'm going to place it right over here. So I'm going to multiply. There's a 1 here, so I'm going to multiply by 5. And how many more x's I need? I need 1 more. Then 5x times x squared gives me 5x to the third. 5x times negative 3 is negative 15x. So therefore, I'm going to place it here. Then what should I do? Change the signs, or multiply by negative 1. This will cancel every single time. Now I'm going to bring down the next term, negative 4x squared plus 15x. And I'm also going to bring down the plus 1. Now sometimes you're not too sure if you need to bring down the plus 1, so you might want to wait until later. And now I go through the process. What do I need to multiply x squared to end up with negative 4x squared by negative 4? Negative 4 times x squared is negative 4x squared. Negative 4 times negative 3 is positive 12. And now what should I do? Change the sign. So we can say positive, and then we can say negative. So therefore, this will cancel out. I end up with 15x and minus 11. And now, according to our rules, once the remainder has a smaller degree than your divisor, then we can stop, and that is the case in here. Your remainder has a smaller degree than your divisor. So now we can write down our answer in this form, which will be here. So therefore, 5x to the third minus 4x squared plus 1. Once it's divided by x squared minus 3, that is going to be equal to 5x minus 4. Now, the same way that we usually, when we write this answer here, so just think about it in this process, right? Let me zoom out. Once we finish here, what do we say? This is, we said that 44 divided by 3 is equal to 12. And 2/3. Do you agree? So the same way that we're going to say that, this is 5x minus 4. I'm going to say plus 15x minus 11 over x squared minus 3. Now notice that ideally we should place a plus in here because it's not multiplying. We never do. But in this case, I do need to see the plus. Example number 3. So take the time to copy or paste your cutout and copy example number 3. See if you remember the process, and we'll start once you're ready. Go and pause it. Excellent. So syntactic division is a process. There's a nice shortcut to the long division of polynomials when divided by divisors of the form x minus k. So remember that x has to have a coefficient of 1. This shortcut is called syntactic division. And this is the pattern. You bring on the a, and then you multiply, you add, you multiply, you add, you multiply. But let's go through a process. It'll make a little more sense. First, let's practice a long division. So that way we know that it's equivalent. So let's go and practice a long division. Am I missing any exponents in here? The degree is 3. So you have x to the third, x squared, x, and then the number. So there are no missing exponents. And let me just make sure that I have enough space. So I'm going to place it up here. We have 5x to the third plus 8x squared minus x plus 6 divided by x plus 2. So go and pause it, work through the long division, see what you get, and then we can work on the syntactic division together. Go and pause it. So the process. It's a process. What do I need to multiply x to end up with 5x to the third? Well, no, I need x squared. So I'll place it here. So it will be 5x squared. And I multiply. 5x squared times x is 5x to the third. 5x squared times 2 is positive 10x squared. Then I multiply by negative 1, or just subtract. Then it cancels, gives me negative 2x squared. Write down the next term, which is negative x. And then we continue with the process. Repeat the process. X times negative 2x squared is negative 2x. Multiply it out, gives me negative 2x squared and negative 4x. And what should I do? Change the signs. We'll multiply by negative, the positive, positive, that cancels. So now I end up with 3x plus 6. And now, repeat the process. X multiplied by 3. 3 times x will be 3x. 3 times 2 is positive 6. Multiplied by negative 1. Cancels, cancels, so my remainder should be 0. Now, let's use syntactic division. In this case, we have x plus 2. So therefore, the x has a coefficient of 1. That means that we can use syntactic division. So what I'm going to do, I'm going to place it x plus 2 equal to 0. And now I'm going to solve. So therefore, x equals negative 2. And that's what I will be using. Correct? So therefore, x equals negative 2. I'll place my L. And now I'm going to only grab my coefficients. So therefore, make sure that you're not missing any exponents, which we're not. So that'll be 5, skip a space, 8, negative 1, and 6. The process. I'm going to place a 0. Then I'm going to add. You multiply. Negative 2 times 5 is negative 10. Then I'm going to add. You multiply. Negative 2 times negative 2 is positive 4. Then I'm going to add. You multiply. -2 times 3 is -6. And then I'm going to add. And this remainder is 0. Now I'm going to take a step down for my exponent. This is x to the third, so therefore this will be one step down, which will be x squared. Then this will be x, and then that'll be the number. So notice that we get the same answer. My answer is, so for both of them, let's write it down as 5x to the third plus 8x squared minus x plus 6 divided by x plus 2 on both of them is 5x squared minus 2x plus 3 with no remainder. But now let's compare and see where are those numbers coming from. So notice that we have 0. Let me use green might be better. Is here. -10 is here. +4 it's here. -6 it's here. Right? So basically, and we're actually not thinking even about this one. So excuse my. So therefore, notice that it's an equivalent process, but then this is just the shorter version. Correct? So let's go through example number 4. Paste your cutout, read through it, write example number 4, pause it, and we'll continue once you're ready. So the intermediate value theorem. Let a and b be real numbers such as a is smaller than b. If p is a polynomial function such as the values when you plug in the a and b are not the same for the function in the interval ab, then f takes on every value between p of a and p of b. If the values p of a and p of b are opposite sign, then there exists at least one real zero of p between a and b. So basically, it's just it's a very simple theorem. Basically, let me go into decimals really quick, and let me just type in a function. Let me actually just type in the function that they give me. Well, first, if I can do this on decimals as well. It does a really good job, and that gives me a point, and that should be on the graph, and it is. So it's some of the connections that you need to be able to make algebraically and graphically in the class. Example number 6. Go ahead and copy it down, pause it, and then we'll continue once you are ready. And actually, let's get rid of this part. We're not doing this yet. So example number 6. Decide whether -3 or 2 is the zero of the function. So we have the following function. So how can we decide if -3 is 0? Correct. So if I plug in a p of -3, if once I plug in a -3, if it gives me a 0, that means that it's going to be 0, -3. Oh, it's going to be 0. So therefore my x value is -3, and my y value will be whatever I get. So therefore, if that's a 0, that will be the x-intercept. Same thing for here. If I want to be able to find out if 2 is a 0, once you plug in a 2, then that will be a specific point. If it's 0, then that will be actually the root or the 0 of the function. So in this case, let's use syntactic division, since that's on the section that we're doing for each one. See what you get for each one, and we'll compare our answers. Go ahead and pause it. Excellent. So in this case, x equals -3 and x equal to 2. Am I missing any terms? No. So we have x to the third is 1, x squared is -4, x is 9, and the constant is -10. And same thing here. Then let's go through the process. Start with a 0, you multiply, you add, you multiply, you add, you multiply, you add, you multiply, you add. Let me just double check my work. 1 looks like a big number. -3, so it gives me 1, -3, -7, +21, 30, -90. So therefore, this is -100. So therefore, not a 0. So now let's try this one. That gives me 0, add, multiply, add, multiply, add, multiply, and bingo. That gives me a 0. So therefore, that means that this is going to be 2, 0, which will make it the x-intercept, which makes it into a 0. So therefore, 2 is a 0 of p of x. Let's go through example number 7, then number 8, and then we'll be done for today. Go and take the time to copy it down, read through the theorem, and we'll start once you're ready. Go and pause it. So the factor theorem. A polynomial f of x has a factor of x minus k if and only if f of k equal to 0. So therefore, once you plug in a k, if the answer is 0, then x minus k is a 0. So that kind of makes sense, right? It's very similar to what we talked about in this section. Once you plug in a 2, then if you end up with a 0, since 2 is a 0, therefore x equal to 2, therefore the factor will be x minus 2. But now we have as a theorem. And now we can use the term that shows that x plus 3 is a factor of f of x. Now to be able to show that this is a factor, that means that once we plug it, since x plus 3, we're going to place equal to 0, move the 3 to the right, we can say -3. Then do you want to do long division or syntactic division? I'm going to use syntactic division, so it seems to be a little faster. Now in this case, you can't just plug it in to end up with a 0 here. We actually have to use the long division because we're looking for my quotient. Am I missing any exponents? Yes, so therefore my coefficient for x squared is x to the third is 1. I don't have an x squared, so I'll place a 0. Then we have a x, which is -19, and then the constant, which is 30. Go through the process and see what you get. Pause it. So it gives you 0. Add gives you 1. Multiply. Add. Multiply. Add. Multiply. Add. Therefore, that gives me 0. Therefore, x plus 3 is a factor. Now, since remainder is 0. Now it's asking us to be able to find the remainder linear factors. So therefore, we are going to write down the function as x to the third minus 19x minus 30. We are going to use the other notation that we talked about in here. So we're going to use this notation instead. Is equal to, this is x to the third, so therefore this becomes x squared. This is x and then the number. So therefore this will be x squared minus 3x minus 10 multiplied by x plus 3. And now we can factor this out. If it factors. Factors of x squared gives me x and x. Factors of 10 will be 5 and 2, 1 negative, 1 positive. And we have x plus 3. So therefore, x to the third power minus 19x minus 30 is equal to those three factors. And if you guys want, we can actually multiply this out to end up with the same expression. But for now, let's do the last example for today. So take the time to copy example number 8, and we'll start once you're ready. So example number 8. Show the x minus 3 is a factor of f of x. Then find the remainder linear factors of f of x. So therefore, they tell us that x minus 3 is a factor. Therefore, if we place equal to 0, we know that 3 should be a 0 of the function, correct? So we have a choice. Do you guys want to use long division or synthetic division? Synthetic division. So go through a process similar to example number 7. See what you get, and then we can compare our answers. Go and pause it. Excellent. So in this case, we have x equals 3. I'm going to use my synthetic division. I'm not missing any terms. The degree is 3, so we have x to the third, x squared, x1, and then the constant. So no, my coefficient is 1, negative 3, 5, and negative 15. And then I start the process. 0. Then I add, multiply, 3, then we add, multiply 0, then we add, multiply 15, perfect. So therefore, since we have 0, the remainder is 0, that means that x minus 3 is a factor. So x minus 3 is a factor, can't spell today, is a factor of f of x since the remainder is 0. Correct? Now, second part, find the remainder linear factors. And the keyword here is linear factors. So therefore, we know the f of x, and let me just work underneath since I need a little more space. So f of x is equal to x to the third minus 3x squared plus 5x minus 15. That will be equal to, let's say this is x to the third, this will be x squared, that will be x, and then the constant. So that will be x squared, I don't need that 0, so plus 5, and I still have my x minus 3. In other words, if I multiply this out, that gives me x to the third minus 3x plus 5x minus 15. And now, am I done? Well, no, according to this, this should be a linear factor. This is a linear factor, which is perfect. So the question is, how can I factor out x squared plus 5? Factors of x squared will be x and x. Factors of 5 will be 5 and 5. Well, does that work? No, but it should. There should be a factor that I should be able to factor it out. So that is the question. So therefore, since this is positive, let's work backwards. So one more thing that we can say, let's work backwards and then we can talk about how we can factor it out. So move the 5 to the right. We know that if we set it equal to 0, that'll be x squared equal to negative 5. And now if we take the square root on both sides, so therefore x, that'll give me an I, so therefore it'll be I square root of 5. Do you agree? And let me not forget my plus or minus. So notice, let's go compare to this part. If x plus 3, so therefore one of them will be x equals I square root of 5, and the other will be negative I square root of 5. Do you agree? So therefore, if we work backwards, it was x equal to 3, then one of the factors was x minus 3. The opposite, correct? So therefore, if this is I square of 5, then this will be negative I square of 5. And if this is negative, this will be positive I square of 5 plus 5x minus 15. And therefore, both expressions are equivalent. And we're going to be talking about factoring this type of binomials or more on the next section. So this will conclude the lesson for today. Have a great day, and I'll see you guys next time.